Hey everyone, we will learn now about the electric power. So far we learned about the electric current, we learned about Ohm's law, we had some few examples about that. Now it is time to introduce to you the electric power and the concept behind it and some of the applications of the electric power, okay? So to start, let's just actually start together here to do that. We know that the power, as we learned in the past, is equal to the energy divided by time. Okay, the energy is, could be energy of gravitational field or electric field or magnetic field, doesn't matter, but we are talking about electric power. So that's the electric energy and coming from the electric field, and we learned it to be equal W, or we also learned it as EPE, the electric potential energy, divided by time. The electric potential energy is equal to Q times the voltage divided by time. Now, if you take this quantity, Q over time is how much charge passes through a wire in a certain time, and that we call the current. So we end up with this equation: power is equal to the current times the voltage. And that's a very important equation. Now there are many other forms for this equation depending on what the problem imposes. So since V equals the current times the resistance, then we can plug in V here. All right, so power is going to be equal I times V, which is times IR, and that ends up to be I square R. So that's another form for the power. Okay, is there a third form? You bet. We can write this in terms of I is equal V over R, and plug I here, so power is equal I times V, but I is equal to V over R times V. So if you do that, then you get power is equal to V squared over R. So you have a third form. So there's three forms. You don't have to memorize all of them if you don't want to memorize any of those. You can just know that the power is equal I times V, and you should know that this equation V equals IR. Then you can plug in back and forth however you feel to be able to solve a problem. Okay? Now the problem dictates which form you should use. Sometimes you have to use this one and this one together, and then you don't have to use any of the other forms. So let's read this example together. We have a 1.5 volt battery that is connected to a 2 mega ohm resistor. Okay, so that's a resistor. It's 2 mega ohm, and the battery is 1.5 volts, and the current is going to go through the circuit. And then let's see what we need to have to do to solve the problem. The first part says find current. Okay, I'm going to solve that here. So V equals IR. Then if we want to find the current, then I is equal V over R, which means that I is equal to 1.5 divided by 2 mega ohm. Mega is 10 to the power 6, so 2 times 10 to the power 6. And if we calculate the current, we get the current is equal to 7.5 times 10 to minus 7 amps. Okay, so we found the current. Let's find the power. All right, we have the current, we have the resistor, we have the voltage, we have so many forms for the power. Maybe I will start with the easy one, I times V. Do we have the current? Yes, we do. We just found it. And we have the voltage too. And when they say power of the circuit, so for this one is going to be equal to the current, which is 7.5 times 10 to minus 7 times here the voltage, which is 1.5. And if we calculate that, we find the power is equal to 1.125 minus 10 to minus 6 watts, because power is measured in watts, and watt is equal to joule per second. Okay. Now the third part, it says find energy dissipated in the resistor after 3 hours. Okay. Energy is equal to power times time. So the power is equal to 1.125 watts times time. Time is in 3 hours, so 3 times 60 to make it in minutes times 60 to make it in seconds. Okay, because we use the unit of time to be seconds, not the hour. And if you do this calculation, you get the energy dissipated in the resistor after 3 hours to be equal to 0.0122 joules. And that's a very small energy, basically. But what happens is that this energy mostly is used as heat and dissipates as heat in the resistor. That's why when you touch any electric circuit, you find that it is a little bit warm. Now let's do this example. A 700 watt iron is connected to a 120 volt source. Okay, what current is flowing into the heater of the iron? That's the first part. The second part is, if it flows for 20 minutes, how much energy is dissipated through the resistor of the iron? Okay, so we know that the power is given, and the power is equal to 700 watts. We are also given the voltage. The battery is equal to 120 volts. All right, we need to find what? The current. So I is unknown. All right. Well, that's again we can use this equation. Power is equal to V times I. The power is 700. Voltage is 120, just like the one you get at home. And this is the current. Then divide by 120 both sides. You get I is equal to 5.83 amps. 5.83 amps. Okay. The second part of the problem, if it flows for 20 minutes, okay, so time is 20 minutes times 60 to get that in seconds, and that's 1200 seconds. Okay, so what are we asking for? How much energy? So energy is equal to the power times time. The power is, we found, or it's given to us as 700 watt, and time is 1200. And if we do this calculation, we get the energy to be equals to 840,000 joules, which is 840 kilojoules. All right, and that's it for this one. Thank you very much.